4.4 Introduction to Related Rates. Many variables have a familiar relationship, or in other words, a way variables are related to each other. A great example is the Pythagorean theorem. Let's say a triangle's dimensions are changing. This means a dimension A, B, or C has a rate of change, and this rate is related to another dimension's rate of change. Differentiate your relationship with respect to one specific variable. This is like implicit differentiation. Usually, it is with respect to time, but not always. Number 1. A police car approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. Next up, set up a relationship, then find an equation that shows the related rates of the vehicles with respect to time. So let's call, well, this is our y, these are x, and let's call this d. So to set up our relationship and we set up our relationship to find an equation. We do d over dt multiplied by x squared plus y squared equals d squared. It's the Pythagorean theorem. Find the derivative. So 2x dx over dt plus 2y dy over dx equals 2d over, or we should have did something that wasn't d, but 2dd over dt. Some dimensions are constants. An airplane, point A, is flying on a horizontal path that will take it directly over an observer, point O. The airplane maintains a constant altitude. Relate the rates of change of the distance between the observer and the airplane and the horizontal distance between the two. First, we'll draw a triangle. Call this H, and then of course X, Y. Y is our altitude, and you know the rest. Pythagorean theorem again is a triangle, so right triangle. So x squared plus y squared equals h squared. Find the derivative. So 2x dx dt plus 2y dy dt equals 2h dh dt. And this becomes 2x dx dt equals 2h dh dt. And then you can cancel out the 2's, and this just becomes x over dx dt equals h for dh dt. Very easy.